Alright, the second part of the test will consist of 4 questions where you have to find exact values of angles and things, like the two that you see in front of you now, and then there will also be 4 questions dealing with solving trigonometric equations. So in looking at these first two where we have to find exact values, you will need to use all of the angles that you know and that we've been taking quizzes on for this entire semester to come up with a way to get to these angles. So with this first one for 345 degrees, I believe the easiest way to get there would be to say that that is the same as 300 degrees plus 45 degrees. And so we would write cosine of 300 degrees plus 45 degrees. Then from our trigonometric identity sheet, we know that the cosine of 300 plus 45 degrees would be the same as saying cosine of 300 degrees, cosine of 45 degrees, minus sine of 300 degrees, sine of 45 degrees. And so with that, the cosine of 300 degrees is 1/2, and the cosine of 45 degrees is the square root of 2 over 2. Then the sine of 300 degrees is a negative square root of 3 over 2, and the sine of 45 degrees is the square root of 2 over 2 as well. Now it's just a matter of doing some math and multiplying. Fractions, of course. So 1 times the square root of 2 is the square root of 2, and 2 times 2 is 4. Minus square root of 3 times the square root of 2 is the square root of 6, and there's a negative there. And 2 times 2 is also 4. And now because these have a common denominator, we can combine them, and if they didn't have a common denominator, you'd have to get one. In this case, it is already 4, and so then we would have the square root of 2 plus the square root of 6 all over 4, and that is the exact value for 345 degrees. Our second example here is the sine of 11 pi over 12. So we need to come up with a way to get to 11 pi over 12. So we have to take something pi over 12 plus another thing pi over 12. Now you could start out by saying, okay, well, let's try 5 and 6. Well, 5 pi over 12 you cannot simplify, and we do not know what the exact value of 5 pi over 12 is. So that would not be a good choice. Instead, you could say possibly 9 pi over 12 and 2 pi over 12, because 9 pi over 12 is the same as 3 pi over 4, because you can divide 9 and 12 by 3. And 2 pi over 12 is the same as pi over 6. Now you could also say 8 pi over 12 plus 3 pi over 12, which would be, if you divide by 4, 2 pi over 3 plus pi over 4. Either one will work. We are just going to do one of them, which is going to be this one. So we are going to say the sine of 3 pi over 4 plus pi over 6. And so then from our trigonometric identities for adding angles together, sine plus of an angle plus another angle, that would be sine of 3 pi over 4 cosine pi over 6 plus cosine 3 pi over 4 sine pi over 6. And so now the sine of 3 pi over 4 is square root of 2 over 2 times the cosine of pi over 6, which is the square root of 3 over 2. And then we're going to add the cosine of 3 pi over 4, which is a negative square root of 2 over 2. And the sine of pi over 6 is 1/2. And then we turn to our math skills again, and square root of 2 times the square root of 3 is the square root of 6 over 4 plus negative square root of 2 over 4. And so, because they have a common denominator already, we can add them together and put it all over 4. So we would say the square root of 6 minus the square root of 2 all over 4 is the sine of 11 pi over 12. Okay, then moving on to solving trigonometric equations. When you're solving these equations, many different routes you can take and things. Mainly you're just going to be using your skills of algebra and probably not have to refer to your trigonometric identity sheet too often. So in this case here we have 3 cosine squared of x plus 5 cosine of x equals 0. And so we want to try to solve this. Because we have both a cosine squared and a cosine, just like if you have an x squared and an x, we can't just move things to the other side. We're going to have to do some things like with the quadratic equation. In this case, because there's only 2 terms, we can try to factor it. And they both have a cosine in them. So let's take a cosine out of each one of them. And when we divide a cosine out of 3 cosine squared of x, you will get 3 cosine x. When you divide a cosine out of 5 cosine of x, you will get plus 5. And so that equals 0. Well, now we have two things multiplied together to get 0, so we applied our zero product property, which then says cosine of x equals 0, and 3 cosine x plus 5 equals 0. And so in this case, x would have to equal the inverse cosine of 0. And so now from our handy dandy circle, where is cosine 0? That would be right here and right there, which are pi over 2 and 3 pi over 2. Then, looking at this other side, we would have to solve this, and we would subtract 5 and then divide by 3, so we would have cosine of x equals a negative 5/3. And so then x equals inverse cosine of a negative 5/3. Now, inverse cosine must be between a negative 1 and a positive 1. And negative 5/3 is not between those two values, so therefore there is no solution for this one because that value is outside the domain of what cosine, inverse cosine can have. So there aren't any angles that would fit that. If you try to put this into your calculator, it's going to say some error message to you that tells you that it's not possible. But we still have these two answers as our angles. And so the only two places where this equation crosses the x-axis would be at pi over 2 and 3 pi over 2. Now if you want to check your answer, you can enter this equation into your calculator and graph it. And then on the graph, I'm not sure exactly how it's going to look, but here at pi over 2 and at 3 pi over 2, you're going to see that it crosses the axis at those 2 points. Now those values aren't going to be given to you that way on your calculator, but they will be given to you in decimal form. And that's the way you can check your answer, or at least you can come up with the answers by graphing to get this. That would get you 1 point out of whatever it's possible. All of this work has to be on your paper in order for you to receive full credit. Our second equation here says 4 cosine squared of 2x minus 3 equals 0. So in this case, because we only have one term here that has a variable in it, we can just use our simple algebra skills to get everything to the other side. So add 3 first. And so then 4 cosine squared 2x equals 3. Next thing you can do is divide by 4 and get cosine squared 2x equals 3/4. After that, we would take the square root. And so then cosine of 2x equals the square root of 3/4, which would be plus and minus the square root of 3 over 2. Then you would get rid of the cosine to say 2x equals inverse cosine of plus and minus the square root of 3 over 2. Now, because we have this 2 here with this, you don't want to just figure out what these angles are between 0 and 2 pi at this point in time, because you're going to end up having to divide by 2, which then is going to shrink all of those angles. So there are some angles past 2 pi that when you divide by 2 that are actually going to be within the range of 0 to 2 pi. So in this particular case, we're going to want to come up with the general solutions first. And so where is cosine square root of 3 over 2 on your circle? That would be at that angle, and this angle, and also this angle, and that one, which this angle is 30 degrees, or pi over 6. This one is 150 degrees, or 5 pi over 6. This one is 210, or 7 pi over 6. And this one here is 330 and 11 pi over 6. We do not need to write all of those down yet, because if you write this angle and add pi to it, you would get to that angle. So that would be saying 2x equals pi over 6 plus pi n. And then if you write 5 pi over 6 plus pi n as well. And so now, if we take and divide by 2, which is the same as multiplying by a half, you will get then x equals pi over 12 plus pi over 2n, and 5 pi over 12 plus pi over 2n. And so now if we're trying to figure out between the interval of 0 and 2 pi, we can come up with the angles. The first one would be pi over 12. If you add pi over 2 to pi over 12, that's like saying 6 pi over 12, and that would be 7 pi over 12. And then if you add another 6 pi over 12, which now would be 12 pi over 12, that's going to be 13 pi over 12, which is still less than 2 pi. If you add another 6 pi over 12, that's going to turn that into 18 pi over 12, and 18 pi over 12 plus pi over 12 is 19 pi over 12, and that is still less than 2 pi. If you add another 6 pi over 12, that would be 24 pi over 12, and 24 plus 1 is 25 pi over 12. And now that one is bigger than 2 pi, so we do not need it. Then moving to this other angle, we have 5 pi over 12. And if you add pi over 2, which is 6 pi over 12, you are going to get 11 pi over 12. Adding another 6 pi over 2, which would make this 12 pi over 12, you are going to get 17 pi over 12. Adding another 6 pi over 12 would make this 18, and 18 plus 5 is 23 pi over 12. And then adding another pi over 2, that would make that 24, and 24 plus 5 is 29 pi over 12, and that is outside of 2 pi, so we don't need it. So we have 8 angles that fit the criteria for this particular equation. And again, if you want to find the answers in the decimal form of all of them, you could try to enter this into your calculator first and graph it, and you would see that between 0 and 2 pi, if you make your viewing window that big, it's going to cross at 8 places. And then you could write those down and you'd get at least 1 point, and then showing all of this fine work would get you the other ones. All right, next equation. Here we have cosecant squared of x minus cosecant of x minus 2. three terms. It has a squared term, a linear term, and a constant term. So therefore, we can use our quadratic properties and rules to solve. And since it has this, we can try to factor it like we would factor x squared minus x minus 2. And the factors of a negative 2 that will add up to a negative 1 would be a negative 2 and a positive 1. So in this case, we would have cosecant of x minus 2 and cosecant of x plus 1 equals 0. And now by the zero product property, each of those can be equal to 0, and then solve, and you would get cosecant of x equals 2, and here cosecant of x equals negative 1. Now we do not have an inverse cosine or cosecant, so we need to change this to something that we do have an inverse of, and the reciprocal of cosecant is sine of x. And since we flip that to sine, we would have to flip that to 1/2. And here we would take this and turn it into sine as well, and that would then turn into a negative 1 because the reciprocal of a negative 1 is a negative 1. And so now x is going to equal the inverse sine of 1/2, which, where is sine of half? That would be at pi over 6 and 5 pi over 6. And where is sine a negative 1? Well, let's see. That is going to be right there. Which is 3 pi over 2. And there we have solved that equation. Again, if you want to try to enter this into your calculator, to do this one, you would have to put 1 over sine of x squared minus 1 over sine of x minus 2 equals, and then graph that. And when you did, it would cross the x-axis 3 places between 0 and 2 pi. Something like that. Our last example is sine of 2x minus cosine of x equals 0. Now in this one we have a cosine of x and we have a sine of 2x, and there really is not anything you can do algebraically with that. So now we're going to have to figure out a way to maybe change something so that we can get it to look like the other thing, or do some things so we have something that is the same. And so we're going to need to look at our trig identity sheet. And we have sine of 2x, which there's a double angle formula for, or a double angle identity. It says sine of 2x equals 2 sine x cosine x minus cosine x equals 0. And would you look at that then? We have a cosine of x in both terms that we have here now, so we can divide out a cosine of x. When you divide that out of this first term, you get 2 sine x. When you divide it out of the second term, you get a negative 1. And so then, setting each part equal to 0 using the zero product property, cosine of x equals 0, and 2 sine of x minus 1 equals 0. So then x is going to equal inverse cosine of 0, and here x will equal inverse sine of 1/2. And so now, inverse cosine of 0 would be right here and right there. So pi over 2 and 3 pi over 2. And the inverse cosine of a half, or inverse sine of a half, would be there and there again, which is 5 pi over 6 and pi over 6. And so there are 4 solutions to this particular equation. Here you could enter this one exactly the way it appears, because your calculator can take in sine of 2x minus cosine of x. And when you graphed it on your 0 to 2 pi scale, it would cross in 4 places. Not there, just there. And there you'd have your 4. And again, those would be the decimal equivalents to all of those. So if you wanted to check to make sure these are right and you graphed it, whatever the decimal number is, you would just take pi divided by 2, and that should equal that coordinate right there. Finally, another question where you have to find some exact values would be something like this. And so with this, we know that sine of u is 3/5 and cosine of v is a negative 7/25. And it says that u and v are both in quadrant 2, which means they're over here. And cosine is negative and sine is positive. Here we're trying to find tangent of u plus v. Well, the rule for tangent of u plus v is tangent of u plus tangent of v all over 1 minus tangent u times tangent v. Well, we've got to figure out what tangent of u and v are. To do that, turn to your friend, the right triangle again. That's angle u, and if sine is 3/5, there's 3, there's 5, which turns that into 4. And so then tangent of u is going to be 3/4. And since it's in quadrant 2, it's going to be a negative 3/4. Looking at our other triangle, we have, that's v, and this is a negative 7. Well, it's just 7, and this is 25 in the triangle, and if you take 25 squared minus 7 squared, you get 24 squared, and the square root of that is 24. It's one of those triangles you should know. And so then the sine, or the tangent of v is going to be 24 over 7. And it's also negative because we're still in quadrant 2. And so now applying these values, you would have a negative 3/4 plus a negative 24 over 7 divided by 1 minus a negative 3/4 times a negative 24 over 7. Simplifying this down then, you have to get a common denominator, which is 28. 7 times 3 is a negative 21. 4 times 24 would be plus a negative 96. And in your denominator, you're multiplying, you'd have 1 minus, and 4 goes into 24 6 times. So you'd have 1 minus 18 over 7. Simplifying the numerator, negative 21 plus a negative 96 is a negative 117 over 28 divided by, and now we have to do some subtracting here, and that would be 7 over 7 minus 18 over 7, because the negative times the negative is a positive 18, and minus is still there, so 7 minus 18 is a negative 11 over 7. And so then dividing in a fraction, here would be taking this then and moving it and multiplying by a negative 7 over 11. And then because 7 goes into 28, that would turn into 1, and that would turn into 4. And you would get a positive, because it's a negative times a negative, 117 over 44. And finally, moving on to this last one, sine of 2v, the formula or the identity for that would be 2 sine v cosine v from your trig identity sheet. And so then we would have 2 times sine of v. And if we're looking at this triangle here, v, sine is going to be 24 over 25. And since it is in the second quadrant, that's a positive 24 over 25. And then cosine is a negative 7 over 25. And now it's just a matter of multiplying 2 over 1 times 24 over 25 times the negative 7 over 25. So the denominator is 625 and the numerator is a negative 336. And that's what the sine of 2v is. And that concludes day 2's test.